Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Let's have a moment of science please. Obstacles are things a person sees when he takes his eyes off his goal. Today's topic is Metals and Nonmetals, Class 10, Chapter 3. In this video, we are going to learn about metals and nonmetals, uses of metals, reactivity series of metals, ionic and covalent compounds, minerals and ores, extraction of metals, corrosion. What are metals and nonmetals? We know that element is a substance that cannot be further decomposed into simpler substance by ordinary chemical means. These elements are further divided into two groups, metals and nonmetals. I have already made a separate video on difference between metals and nonmetals, both physical and chemical properties. Link is given in the description box. Uses of metals. Copper and aluminium are used to make wires as they are good conductors of electricity. Iron, copper and aluminium are used to make utensils and equipments due to their malleability, hardness and good thermal conductivity. Zinc is used to protect iron from rusting. The process of placing a protective coating of zinc on iron is known as galvanization. Copper and aluminium form a protective oxide layer on the top and prevent the rest of the metal from corrosion. Aluminium is used to make foil, packaging in medicines, cigarettes and food material. Gold, silver, platinum are used to make jewelry. Mercury is used in thermometers. Nickel, titanium, zirconium, uranium are used in nuclear energy. Reactivity series. We have seen that some metals react immediately while others react slowly and some do not react at all. Reactivity series is the reactivity is the tendency of chemical substance to form a product by itself. Reactivity series is an arrangement of metals and nonmetals on the basis of their tendency to react with other elements. The elements are arranged in the series in decreasing order of their reactivity. As you can see here, the metals which are more reactive are on the top of the series, while the metals which are less reactive are at the bottom of the series. Ionic compounds. Compounds formed due to the transfer of electron from metal to a non-metal are known as ionic compounds. In this course, metal get positively charged because of the transfer of electrons and non-metals get negatively charged because of acceptance of electrons. In other words, bond formed between positive and negative ion is called ionic bond. Thus, the compound formed is electrically neutral. For example, sodium chloride. As you can see here, sodium, whose atomic number is 11, electronic configuration is 281. Number of electrons in the outermost orbit or valence electrons is 1. While chlorine, atomic number is 17, electronic configuration 287, valence electrons are 7. So here, the one extra electron of sodium is transferred to the chlorine and chlorine accepts it and both of them become stable by forming sodium chloride. Similarly, magnesium chloride is also formed by ionic bond. So you can see here the magnesium, atomic number 12, electronic configuration 282, and chlorine's atomic configuration is 287. So 1 electron of magnesium is transferred to the chlorine, and chlorine accepted to form magnesium chloride. Properties of ionic compounds. These are normally solid at room temperature. They are generally hard due to strong force of attraction between the positive and negative ions. They have high melting and boiling point because a large amount of energy is needed to break the intermolecular ionic bonds. They are soluble in water, however, they are insoluble in organic solvent like kerosene and petrol. They do not conduct electricity in solid state as there is a high force of attraction between oppositely charged particles, so the movement of electron is not possible in rigid or solid structure. However, they conduct electricity in molten and liquid state. Covalent bonds, these are formed by sharing of electrons between two atoms. Example is hydrogen, chlorine, water molecules, etc. Formation of hydrogen molecule. Each atom of hydrogen having one electron shares its electron with each other to make a hydrogen molecule by forming a covalent bond between them. Formation of water molecule. As we know, oxygen's atomic number is 16. So it has electronic configuration 286, 6 valence electrons, and need 2 more to complete its outermost orbit. Hydrogen atom, each having one valence electron, shares its electron with oxygen, forming H2O water molecule and thus forming covalent bonds, as you can see in the picture. Minerals and ores. Minerals. Elements or compounds which occur naturally in earth crust are called minerals. They may or may not contain metals. Example, salt, clay, marble. Ores. Those minerals which contain a very high percentage of a particular metal from which the metal can be profitably extracted are called ores. Example, aluminium metal is extracted from bauxite ore. Iron metal is extracted from hematite ore. Sodium metal is extracted from rock salt. How are different metals found inside the Earth's crust? The Earth's crust is a major source of metals. Seawater also contains some soluble salts like sodium chloride and magnesium chloride, etc. Reactive metals do not occur in their free state. Metals like potassium, sodium, calcium, magnesium, aluminium are found in combined state as sulfides ore or oxide ore. Less reactive metals like silver, gold, copper are present in their free state. How do we obtain metals from its ore? The ore of the metal is not a pure metal that we directly use. The ore has impurities and metal must be obtained from its compound. The process of removing impurities from the ore is known as concentration or enrichment. After the ore has been concentrated, the metal can be extracted from the ore and the process is known as extraction. Extraction of metals. Metals can be categorized into 3 parts on the basis of their reactivities: most reactive, medium reactive, and least reactive. The 3 major steps involved in the extraction of metal from its ore are concentration or enrichment of ores, extraction of metals or conversion of concentrated ore into crude metal, refining of impure or crude metal. First, concentration of ores. The process of removal of unwanted particles or gangue from the ore is known as concentration. Gangue is an unwanted impurity like sand, rocky materials, mica, limestone, etc., which are present in the ore. The method of removing gangue from the ore depends on the difference in the physical and chemical properties of ore and gangue. Concentration is done by various methods. First method is hydraulic washing. A rapid stream of running water is used to wash the ore. The lighter impurities are washed away while the ore remains. Example is washing ore of tin and lead. Second is magnetic separation. Magnets are used to separate gangue and ore. Either the gangue or the ore is supposed to be attracted by magnets. For example, iron is attracted by magnets, whereas its ore hematite is not. Extraction of metal from the ore. Extraction method depends upon the reactivity of the metals. So you can see the chart of different reactive metals and their extraction. Extraction of less reactive metals. Metals low in reactivity series are very unreactive. The oxides of this metal can be reduced to metal by heating alone. These include metal like mercury and copper. Extraction of mercury metal. As you can see here, mercury sulfide or cinnabar is first heated in air. It turns into mercury oxide by liberation of sulfur dioxide. Mercury oxide so obtained is again heated strongly and reduces into mercury metal. Extraction of copper metal. Copper glance is roasted in the presence of air. Roasting turns copper glance into copper oxide. Copper oxide is then heated in the absence of air and it reduces it into copper metal. Roasting, it is a process of converting sulfur ores into oxide by strongly heating in the presence of excess air. Extraction of moderately reactive metals. These metals exist as sulfides or carbonates in nature. Before reduction, metal sulfide or carbonate must be converted into metal oxides. Sulfide ore is converted into oxide by heating strongly in the presence of excess air, known as roasting. Similarly, carbonate ores are converted into oxide by heating in limited air, known as calcination. As you can see here, in roasting, zinc sulfide is turned into zinc oxide, and in calcination, zinc carbonate is turned into zinc oxide. The metal oxide are then reduced to the corresponding metal by using suitable reducing agent such as carbon. So zinc oxide in the presence of carbon gives zinc metal. Obtaining metals from the compound is called reduction reaction. Extraction of reactive metals. Highly reactive metals like potassium, sodium, calcium, magnesium and aluminum do not have stable oxides. They cannot be reduced by carbon or reducing agent. These metals are extracted by electrolytic reduction of the molten chloride or oxides. Electrolytic reduction. In this process, electric current is passed through the molten state of metal ores. Metal being positively charged is deposited over the cathode. For example, when an electric current is passed through the molten state or solution of sodium chloride, sodium metal get deposited over the cathode, and metal obtained from this process of electric reduction is in the pure form. As you can see here, sodium gives at cathode sodium is collected, at anode chlorine is collected. Refining of metals. Many metals such as copper, zinc, tin, silver, gold, etc. are refined electrolytically. In this process, impure metal is used as anode and the strip of pure metal is used as cathode. The solution of metal salt is used as an electrolyte. As you can see in the picture, when the electric current is passed through this, the impure metal from the anode get deposited in the electrolytic solution, whereas the pure metal from the electrolyte is deposited at the cathode. Corrosion. Gradual destruction of pure metals by the action of air, moisture or chemicals such as acid is known as corrosion. Corrosion of iron is called rusting. When an iron object is kept in a damp air for considerable amount of time, the reddish brown substance called rust is formed on its surface. As you can see in this picture, ferrous oxide, also known as rust, is formed. Similarly, silver reacts with moist air and become black due to the formation of silver sulfide coating. Prevention of corrosion. Rusting of iron can be prevented by oiling, galvanizing, painting, greasing, etc. To protect steel from iron and iron from rusting, a thin layer of zinc is coated on them, known as galvanization. Alloy. Mixture of two or more metals or metals and non-metal is known as alloy. Example is brass is an alloy of copper and zinc, bronze is an alloy of copper and tin, and solder is an alloy of lead and tin. Thanks for watching. Please do like, share and subscribe.